Hello, my name is Namtos Dan, and I'm in group 3. And our problem is about, our project is about high disease detection using graph neural networks. And this is the link to the paper that I've reviewed. It was written by Tong Chen. Yes, this is the problem statement and the statistics about heart disease in the world. Yes, yeah, it's says that 17.9 million deaths of people die, and that's out of 32% global mortalities. And yes, possible causes are tobacco use, unhealthy diet, obesity, and physical inactivity, and like also taking alcohol excessively. Then from the literature review, most researchers used traditional machine learning models, and yeah, some of them combine them with deep learning, and these are the models that they used. And then he chose to use the GNN graphical neural networks, yes, of which he used both all the three models, or graphical convolution network, graph stage, and graph attention networks. And then he did this in 2 stages from the data he got from the data set which he got in tables, converted them in graphs, and then converting the graphs into the final result, which is this stage here, graph neural prediction. And then here, from like what I've said above graphically here, grammatically, if you see that he had the data in form of tables, and then into the matrices, then into graphs, and then graphs, he used the models in order to get the prediction. And here it's just giving us how, like, showing us that you can have different graphs, different groups of people with the same characteristics or same features, but no matter the order, no matter how they come, you'll always get the final the same result, whether they have the disease or not, depending on the characteristics. And then here it's just showing us how with this model creates relationships between different people and different characteristics. An explanation is here on the right. How for example, if this person A has features like chest pain, they have high blood sugar and high blood cholesterol, it's going to connect this with another person in the graph. Yes, are they having the same features? How are they connected? And that's how it is able to predict if the person has a disease or not. And then, yeah, how it works, it works in a way that, how I've explained above, not classification according to, these nodes are like people, the patients, classifies them. And then according to their features or similarities. Then the graph classifications can be a group of people, and then classifies them according to their similarities. Then graph visualization is like representing this data into a graph, and then link prediction, creating patterns among patients according to the information stored in the model, and also like the features, similar features this new person is having with the existing people. And then he also used he has other models, traditional machine learning models, which are logistic. He used logistic regression, naives, multi-layer perception, possibly to compare the results he's going to get in this and then the GNN model. So for the model evaluation, he used a data set from UCI, and this data set has 76 attributes, but used only 14. And the 14th is a target. So on the right here, this one in blue are the people who did not have the disease, and the orange are the people who had the disease. So it was kind of almost balanced. So he went ahead in the model evaluation to calculate the accuracy, precision, recall, and F1 score, and these are the results he got. I'll explain them below. We see that the GAT performs optimally I've mentioned them above in the GNN models, and these are the results he got. Then in the traditional machine learning models, naive Bayes performed better, and then graph search performed worse in the GNN. Then multi-layer perception performed the least in traditional models, and this is a representation of the results he got. My observation, the strengths are that this model, it's good in a way that he didn't use only one in the GNN, he used all the three. So that's an advantage. Then robustness, being able to connect relationships from different people, from different features, and coming up with the results. Then it is also an improved version from the traditional machine learning models. Also, it's optimal. With possible weaknesses, he used a small data set which had only 303 instances, and there was a false formula. It was an incorrect formula of the precision, and this is the correct formula for getting precision. And then another weakness is that this model is very complex to use. Then another thing is about this, what he said about many cases coming from low-income, low developing countries, which I didn't 100% agree. And when I went online, I found out that this person, Gazian, and the other authors are also saying the same thing. Then possible biases is that when you go back here in the table, we find that here, these models, logistic regression and naive Bayes, they got the same results, but he says that naive performed better than LR, which is a bias because they had the same results. Then the data set is also too small, which the graphs need a lot of data, large data sets to produce good results, accurate results. And then from also another thing is that small data sets, or like continuation of this point, we see that CGN and graph sets cannot be able to differentiate these graphs because they're having the same nodes. They can give the same output. If people have similar features but are suffering from different diseases, won't be able to differentiate the diseases. The computational problem, you see that the data set is too small for the training. You can't train a model on very small data. And then this model is also very complex. We see from the diagram here, getting a relationship between these data points is really complex. It's hard to trace from where an output has come from. Then in a conclusion, I agree with him in using graphical neural networks because it helps to identify many relationship among the data which you are not able to see. And then for the weaknesses and the computational problems, for example, the weaknesses where he used a small data set, he would have used a larger data set. That's a solution to that problem. And also being keen on the formulas, because any small mistake you make in the data, it can be able to affect it has a very great negative impact on people. This is our health sector. Playing with it can affect people's life. So yes, in general, this method is better than the traditional machine learning models. Yes, that's my review, and I remain to Stena. Thank you so much.